The 14th new feature in ODEON 13 I want to talk about is manual setting of onset time and truncation time for measured impulse responses. So what is this and why do you want such a thing? Well, let's have a look into ODEON. So in this case I will make use of this series of hand clap I recorded, and if we load this time multiple times we might have a chance to analyze the data of it multiple times. So each of these impulse responses, hand claps, can be played back separately. Let's just have a listen to the file. Pretty awful recording with lots of hum from fan on a computer in the room where it was recorded. So I have it 3 times loaded. So let's tile the window so we have them side by side, and then by pressing the O shortcut here we can enable onset time snapping. So I'll do that. I'll select each of the windows and select the manual onset time. So you can do this in the impulse response window, but you can also do it in the squared impulse response window, which might be preference or not. I'll just do that so you can see that indeed it works. So we selected 3 impulse responses, 3 different hand claps, and let's have a look at the parameters. So here we have energy parameters, and this helps me to explain that indeed hand claps can be used for measuring data, measuring room acoustic parameters, and in some cases they might be quite a doable way to obtain at least some draft or sketchy or snapshot recordings of room acoustics in a room. So when you're there you can use mobile phone to record impulse responses and then analyze it here. So we have 3 different hand claps, and let's see if we have the same data. When it comes to EDT, there can be quite some difference here. It's not very precise. But when we look at a parameter like T30, we can see that indeed we have almost the same value. So 0.54, 0.53 and 0.51 as a reverberation time at 1000 Hz. At low frequencies we're not able to obtain any data, so that's not so much of a surprise because there's little acoustic power in a hand clap, but then you could use a balloon or something. So this just showed that we can use indeed a manual onset time to extract different impulse responses from a series of hand clap. What I could also show is one of the pre-installed examples we have with ODEON. So here in my measurement folder, if we take this error, that's a typical time example where we get wrong onset time detection by ODEON, and that is when there is what we call magnetic feedback. That is, if you have your microphone cable and your loudspeaker cable very close to each other, you'll see that you actually get an impulse at time almost 0 because it's at the speed of light or electromagnetism. So this is not acoustic phenomenon, it's pure electromagnetic feedback which arrives before the direct sound. So the correct onset time should be over here, and let's try and see if we can set our correct onset time. So we do it like this, and that, yes, you can indeed see that now we have the correct onset time. ODEON's automatic mechanism was tricked by this very strong pre-impulse, which is incorrect, and now we've set it correct, and ODEON has detected it correct, so parameters will be derived correctly. If we didn't correct this, then parameters like clarity, early energy fractions, EDT and so on would be quite incorrect, so it is important to correct such obvious errors when they occur. So this was on manual onset time. I also spoke about manual setting of truncation time, and let's have a look at this impulse response from a large cathedral. It's the Hagia Sophia or mosque in Istanbul. today a museum. Let's scroll through the frequencies, and you can see indeed here we have something that is a little bit awkward. There has been some bump on the decay. Probably somebody dropped something on the floor. There was some background noise in the room while the sweep was measured. So indeed you can see in the squared impulse response it's easier to see there's something wrong here, and indeed the truncation time shouldn't be here. It should be somewhere, well, maybe here or even up here, because it doesn't really seem very clean. So by pressing the T shortcut, you can see the shortcuts up here in the menu, T. You're able to select another truncation time, and that's what I did just here. And then you will derive the parameters. In some cases it might not be possible. Let's look here at the parameters. There's a few down here at 63 Hz where the impulse response now is simply too short, but at 4 kHz too. It's also where I made the manual truncation time, it's too short to obtain T30. So that was the limitation there. But we can obtain T20 and T15 and EDT and so on. And indeed, if we're using the original suggestion by Odeon, which included this bump notch on the decay curve and squared impulse response, then we would got far too long reparation time. So this was about manual truncation, manual onset time, and how it's used in Odeon. And as you can see, it's fairly easy to use, really. So I hope you find this useful when a rare occasion is you need to do it manually. Thank you for taking your time to watch this video.